Hi, I'm Dr. Jason Brinkley, and this is What's a Measurement? So what is a measurement? A measurement is a way to quantify the world around you using some sort of measuring device and a unit. As you can see here, we have a tape measure that is measuring in centimeters. We've got a blood pressure cuff, which actually measures in millimeters of mercury, in case you were ever wondering what the numbers meant. And then we've got different measuring devices for volume. So length, pressure, and volume are just some of the measurements that we use in science to help quantify the world around us. So what is a measurement? You use a measuring device. Now, a measurement is going to include certain numbers, okay? All the certain numbers plus one uncertain number. This is a number that comes from estimation, okay? So this is different from counting. Counting are exact numbers, whereas this is a measurement. Measurements always have a degree of uncertainty due to the measuring device and the operator's skill. So here we have a coin with what looks like Bill Clinton on it, and it is certain that it is past the 1 and it is past the 2. It is not certain where this digit is here. So Team A says they're measuring it at 2.0 centimeters. They're saying it's directly on that 2. The other one says it's directly on the 3, and one says it's directly on the 2.5. Whereas Team B says it's 2.2 all the way around. Now to me this looks a lot more than 2.2. It looks to me like to be 2.5. But 3 and 2 are not definite measurements for this, especially the 3. That's way overstating the size. Now this brings up the concept of precision and accuracy. Precision is how close a series of measurements are to each other. And accuracy is how close a measurement is to the true value. Measurement. Is to the true value of the measured quantity. So the true diameter of that team, or of that coin, was 2.5. So Team A had one that was directly on and 2 that were far apart. The 2 students were inaccurate, although the average of the team's results is accurate, because 2 plus 3 plus 2.5 averages out to around 2.5. The true diameter, Team B, they were all very precise. All those measurements were very close to each other, but they were not very close to the true diameter. Now, what we like as scientists are accurate and precise measurements. That's what we strive for, accuracy and precision. You can have one without the other, but you can't be certain of your results unless you have both precision and accuracy. Now, there are different ways to make measurements. There is the digital and the analog style measurement. Digital measurements, you record all the numbers on the readout. That includes your uncertain digits. So, for example, on this nice little caliper here, that last digit is our uncertain digit. Okay? In analog measurements, we record all known digits and one uncertain number based on estimation. We estimate that last digit. That's where analog requires a little bit more skill than digital measurements. And we know this because when we were learning how to tell time, nobody wanted to learn how to tell analog time. We all wanted a digital watch. Now, uncertainty, as I have said, there is always an inherent uncertainty in measurements. You can't get away from it. It's impossible. It's due to the quality of the measuring device, due to operator skill, and due to random error. So, the concept of uncertainty is best displayed by this cartoon. This dinosaur bone is 65,023,000 years old. Well, how do you know that? Well, it was dated as being 65 million years old, and I got it 23 years ago. So 65 million and 23. That's kind of silly, right? We assume a certain uncertainty, which makes no sense. Assume a certain uncertainty. We assume a particular uncertainty whenever we see a measurement, and that is the plus or minus 1 of the last digit, because that last digit is the uncertain digit. We assume that the uncertainty is plus or minus 1 of that last digit, unless told otherwise. You can be told otherwise, but this is, in general, what we take as our standard uncertainty. Now, I urge you to test yourself from the textbook problems from Introductory Chemistry, Atoms First, 5th edition by Russo and Silver. And I will catch you on the flip side. Have a great week.